Now let's have a review on how to find the GCF of a number or expression. At first, what is a factor? It is a number or quantity that when multiplied with another, produces a given number or expression. So for example, ang given natin is 6. So the factors of 6 are 1 and 6, 2 and 3. Because when we multiply 1 and 6, it will give us a product of 6. And also, if we multiply 2 and 3, it will give us a product of 6. Now, let's try. Let's find the GCF of the following expressions on numbers. So the GCF is the greatest common factor. Let's have number 1, 3 and 6. To find the GCF of 3 and 6, let us enumerate the factors of 3. So the factors of 3 are 1 and 3. When we multiply 1 and 3, it will give us a product of 3. How about the factors of 6? So from our example, we have factors 1, 6, 2, and 3. So these are the factors of 6. So from these factors, let us compare. So we have common factors 1 and 3. So from the common factors, which is greater, so we have 3. So that will be our GCF. 3 will be our GCF. It is the greatest common factor of all the factors. Okay. Next. So let's have 5, 10, and 15. Enumerate the factors of 5. So when we multiply 1 and 5, it will give us a product of 5. How about 10? We have 1 times 10 and 2 times 5. 15. So 1 times 15 and 3 times 5. So these are the factors of 15, 10, and 5. Now from these factors, let's get all the common factors. So we have 1 and 5. Oops. One and 5. So from 1 and 5, what will be our GCF? The greatest common factor is 5. Okay? Okay, now, what if we have these expressions? How do we get the GCF of this? First, we're going to expand each expression. Now, we have the same base, so the exponent will tell us how many times the base will use as a factor. So our base here is x, so how many times x will be used as a factor? Just look at the exponent. Okay, how about x to the fifth? How many times x will be used as a factor? Okay, so from there, how many are common? 1, 2, 3. So our GCF for this expression is x cubed. Okay, so what if we have an expression like this? So let's have n squared x squared. So if we expand this, we have 2n's and 2x's. So for the next expression, we have 1m and 2x's. 3x's. So from these factors of each expression, what are common? So we have x. Therefore, our GCF is how many x? Okay, so what if we have this expression? So let's deal with the numerical first. 9 and 12. So the factors of 9 are 1 times 9 and 3 times 3. We will just write 3 ones. 12, the factors of 12 are 1 times 12, 2 times 6, and 3 times 4. So these are the factors of 12. So from these numbers, which are what are common? So we have 1 and 3. So what will be our GCF? For the numerical, we have 3. How about with the literal coefficients? So if you will notice, if we have the same base, our GCF will be the one with smallest exponent. So that will be y cubed. In this case, we'll have the GCF of, for this expression, we'll have the GCF of 3y cubed. This is Mom Ronnie. See you on my next video. Bye.